Now we are at the last section of worksheet 4, whereby we will learn about circuits with single solenoid valve. So as you can see, this is the directional control valve. It only has one solenoid. So this is a single solenoid valve. And we learned earlier that single solenoid valve have electrical memory, okay, unlike a double solenoid valve which has pneumatic memory. So let's first go through what do we mean by electrical memory.
Electrical memory is actually a circuit using single solenoid spring return valve, and it needs to have its electrical signal stored there, and hence is said to have electrical memory. Okay, what does it mean? Okay, so basically, in order to make this cylinder extend, I need to constantly energize this solenoid. Okay, the keyword here is constantly turn on this solenoid. Okay, the moment you switch off the signal at the first solenoid, okay, what happens is it will go back to its spring position and it will make the cylinder retract, as you can trace the airflow path here. Okay, so single solenoid directional control valve is said to have electrical memory because it doesn't remember its last position. Hence, you need to constantly turn on the solenoid in order to make it extend in this example over here.
Now, we shall take a look at single solenoid directional control valve and how does it behave. So you can see that the default position of the single solenoid directional control valve is at this position, okay, which is the spring position. Okay, at the spring position, you can see that the air supply will go through the directional control valve to the rod side of the cylinder, okay, and come back to the exhaust. Okay, so when it's at spring position, cylinder will retract. So if I want to make the cylinder extend, I need to energize solenoid 1 over here using this control circuit so that the valve will switch to this position to make the cylinder extend. So let's visualize this control circuit first. When I press 1 PB, 1 CR will turn on, contact will close, the solenoid will be energized and the cylinder will start to extend. Okay, so let's watch this now. So I press and hold 1 PB, 1 CR is on, contact is closed, solenoid is energized, the cylinder is extending because it's at this position. However, the moment I release 1 PB, can you see the valve immediately switch back to this position, which is the spring position, because there's no more power to the solenoid the moment I release 1 PB. As 1 CR coil is de-energized, contact will go back to open, solenoid is off. That's why it is retracting now. Okay, let's watch again. When I press 1 PB, solenoid is being energized. However, the moment I release 1 PB, cylinder immediately retracts back because it goes back to spring position as the solenoid is now de-energized. Okay, it's off. So what does this tell you about single solenoid directional control valve? It needs electrical memory if you want the cylinder to extend and goes all the way to extended position. Okay, so in other words, in order to make the cylinder extend fully, I need to constantly energize the solenoid. Okay, with this current circuit now, it will not constantly energize the solenoid because the moment I release 1 PB, okay, like what I'm doing now, I press 1 PB, solenoid is energized. The moment I release 1 PB, you can see the solenoid is off, okay, and the cylinder immediately retract back because it is at this directional control valve position. So let's go back to the worksheet now to understand single solenoid directional control valve better and how we can design the circuit to control a single solenoid directional control valve efficiently. Earlier in the simulation circuits, you will understand that single solenoid directional control valve have electrical memory. So over here, I want to emphasize again what it meant by electrical memory. Okay, so you can see that this is the directional control valve. The default position of the single solenoid directional control valve is at this position, which is the spring position. So when the directional control valve is at this position, you can see that the air will go in from the rod side to make the cylinder retract. So I will label here when directional control valve is at this spring position, which is at this checkbox over here, cylinder will retract. Okay. However, when you energize this solenoid over here, okay, the directional control valve will switch to this position, okay, which will make the cylinder extend. Okay, as you can see earlier in the simulation diagram. So if the single solenoid over here suddenly has no power, okay, or is being de-energized, the directional control valve will immediately spring back to spring position, okay, which is this position, to make the cylinder retract, okay. So this is the key difference between a single solenoid directional control valve as compared to a double solenoid directional control valve, which have pneumatic memory, okay. So let's take a look at this question first. So when the push button 1 pb is being pressed momentarily, the cylinder will extend and reach the end position. When another push button 2 pb is being pressed momentarily, the cylinder will retract to its original position. So let's write down the flow of this question first. So when 1 pb is being pressed momentarily, okay, this is the key word here, means you press and let go, okay, the cylinder will extend, okay, and it will reach the end position and stays there until when you press 2 pb, cylinder will then retract, okay. So just to recall again, earlier we have mentioned that A means cylinder A, plus means extend, okay. So over here there's only one cylinder, okay, so I'm talking about A extend and A retract. Cylinder A extend, cylinder A retract, okay. So now let's take a look at this electrical ladder diagram. First, we always look at the purpose of the control relay. As you can see over here, this 1CR control relay contact is here, okay, and the contact of the 1CR is being used to control the solenoid, okay. So in other words, when 1CR coil is being energized, the contact will close and the solenoid will turn on, okay. What happens when the solenoid turns on? As you can see over here, I already labeled the diagram. When the solenoid is energized, the cylinder will extend because the check box is at this position, okay. So it's good to write down all these to help you to solve the question. So I will just write here, when 1 SOL is on, the cylinder will extend, okay. This is for my own notes, okay, to help me to solve the question. And when 1 SOL is off, okay, you go to the spring position, the cylinder will then retract, okay. So with this, I know that the purpose of 1CR is to make the cylinder extend and retract. Okay, so how do you energize 1CR to make solenoid on, turn on, okay? So can I just draw a straight line over here like what I have shown you earlier in the simulation circuit? The answer is no, because the question says when 1 pb is being pressed momentarily, means that first you press, okay, 1CR will turn on, correct? Contact will close, solenoid will be energized, the cylinder will start to extend, okay, but the moment you let go of this 1 pb, no more power to 1CR, okay, the contact will stay open, the solenoid will be off, the cylinder will immediately retract. So we cannot make the cylinder extend, okay, properly. So how do we achieve continuous power to 1CR so as to close the contact over here to make solenoid turn on when 1 pb is being pressed, okay? You have learned this before. All you need to do is to create a latch, okay? So let's look at the concept again. When you press 1 pb, 1CR coil will turn on, the contact will close, both contacts will close, solenoid will turn on, and because the contact over here close, 1CR will turn on forever now, okay, even if you let go of your 1 pb, okay, we know about this earlier. So now, how do I turn off the solenoid? I need to turn off the solenoid to make the cylinder retract, right? Because the cylinder needs to retract. So they told me 2 pb when you press, cylinder must retract. So to make cylinder retract, I just need to off the power of 1CR. How do I off? Well, obviously, you put it over here to break the circuit, okay? And I will put 2 pb because the question says when you press 2 pb, cylinder will retract. So what should you draw here? Of course, you will draw 2 pb, okay? So should you draw normally closed or normally open? Okay, let's try to draw normally open and visualize. Okay, do you think this circuit will work? The circuit will not work. Why? Because even if you press 1 pb, your 1CR will not even extend. Correct? So I cannot draw 2 pb as normally open. I need to draw as normally closed. Okay, so let's analyze again. When you press 1 pb, because 2 pb is normally closed, 1CR will be energized. the contact will close, solenoid will turn on, cylinder will extend. Okay, when you press 2 PB, you cut off the circuit at 1 CR. Okay, no more power to 1 CR. Contact will be open, goes back to original position, which is normally open. Solenoid will be off, cylinder will retract. Okay, so this is how you can achieve two directional control, okay, extend and retract, using a single solenoid directional control valve. Okay, so this is how this circuit works. Now we will look at the simulation circuit for this again. Now we are back to the simulation circuit, and I'm going to show you how this control circuit is going to work for this single solenoid directional control valve. As you can see, the directional control valve is currently at retractor position, which is at this spring position over here. So the moment I energize the solenoid, the cylinder will start to extend. Okay, and we need to constantly turn on this solenoid in order to make the cylinder extend fully. Okay, so as I've explained to you earlier in the worksheet, we need the solenoid to be constantly powered on, and to achieve that, we just need to draw a latching circuit. So let's visualize how this latching circuit is going to work. I'm going to press 1 PB momentarily, okay, and you can see that the control relay coil will be energized. The contact will change to close. Okay, so let's watch this. 1 PB is pressed and let go. Okay, so you can see 1 CR is turned on and is constantly powered on by the latching circuit, and the contact will close because the coil is energized. The cylinder will extend because solenoid is on. You can see that as long as you constantly power on the solenoid, okay, the directional control valve will stay at this position and the cylinder will stay fully extended there. As you can see, because solenoid is energized, okay, and is still being energized, the valve position is at the solenoid position, hence the cylinder stays this way. How am I going to make this cylinder retract? The only way to make the cylinder retract is to de-energize the solenoid. Okay, that means you off the solenoid power and the directional control valve will go back to this spring position to make the cylinder retract. So let's watch this. When I press 2 PB, I'm going to break the circuit, which means that 1 CR will be off. Okay, when a coil of 1 CR is off, the contact will go back to open position and solenoid will be off as well. Hence, it goes back to spring position. So let's watch this. When I press 2 PB momentarily, okay, 1 CR is off, contact all open, solenoid is off. Okay, you can see that the cylinder starts to retract back to the retracted position. Okay. So let's watch this simulation again. When I press 1 PB momentarily, solenoid is being energized, cylinder will start to extend. Okay. And once it reaches fully extended position, okay, it will stay there. Okay, because the cylinder is fully extended and because the solenoid is still energized, it will stay in this valve position. Okay, so I'm going to break the circuit, which means that I'm going to off one solenoid. So I'm going to press 2 PB momentarily. 1 CR is off, the contact will go back to open, the solenoid will be off, the cylinder will start to retract because it is back to the spring position. Okay, as the solenoid is off. Okay, so now let's go back to the worksheet. Now we are back to the worksheet and we shall look at automatic return circuit. So you can see over here there are two pneumatic drive circuit. Okay, this is a single acting cylinder, this is a double acting cylinder because of 2 air port, single acting cylinder because of only 1 air port. This one is using a 3 two-way normally closed single solenoid directional control valve. This one is using a 4 two-way single solenoid directional control valve. And as you can see, both are using single solenoid directional control valve. So the control method will be identical. Okay, so what did the question want us to do? It says that when a push button is actuated, the cylinder will extend to its fully extended position and then retract automatically. Okay, so there will only be one push button in this circuit. Okay, and how do we know that the cylinder will extend to its fully extended position? The cylinder has no eyes, so how does it know that it has reached there? Well, you can introduce a limit switch over here, okay, which is what I'm drawing now, so that when the cylinder is fully extended, you will activate this limit switch, okay, to close it or open it, depending on the question, okay. So this question also the same. When the cylinder is fully extended, you will activate the limit switch. So how are we going to draw the control circuit over here? So let's take a look. First, we draw the flow of the diagram. When 1 PB is actuated, the cylinder will extend. And how do I know it reached its fully extended position? 1Ls, and then it will retract. Okay, with this, let's look at this circuit diagram first. Okay, first we must find out the purpose of 1CR. As you can see, 1CR is used to control the solenoid. Okay, so the purpose is to make cylinder extend and retract. Okay, so how do you make the cylinder extend? Well, when you press 1 PB, 1CR will turn on, and this latch will continuously power on the control relay, correct? And the solenoid will be energized and the cylinder will extend. So when do you want to off the power to 1CR so that solenoid will have no more power, the cylinder will retract? Well, I just need to draw the limit switch here. So take a look at this limit switch now first. Is this limit switch activated in the initial diagram? No, it's not. So I can either draw normally open or normally close. So there are two answers I can draw: normally open or normally close. Okay, so which one should I put in here? Okay, let's try the normally open first. Okay, do you think this will work? No, it will not work. Why? When you press 1 PB, okay, you can't even turn on 1CR because your limit switch is normally open. Okay, and it will not be activated until your cylinder is fully extended. But because you are not providing any power to your solenoid, your cylinder will never extend. So this is wrong. Okay, so I need to draw normally close. Okay. Okay, so let's take a look. When you press 1 PB, and because the limit switch is normally closed at the start, okay, 1CR will turn on, solenoid will be on because the contact will close, cylinder will extend. Okay, however, when the cylinder is fully extended, 1LS normally closed will become normally closed held open. Okay, it will break the circuit, 1CR will be off, 1CR contact will go back to its original position, which is normally open, solenoid will be off, cylinder will immediately retract. Okay, so this is how we do this question. Next, the question asks, can we use a normally open limit switch? Well, I know that I cannot use directly in here, which I explained to you just now. But can I think of a way just to use this normally open limit switch? Yes, I can. Okay, so to use this normally open limit switch, I cannot draw it here. Okay, because if I press 1 PB, your 1CR will never turn on, your solenoid will never be on, your cylinder will never extend. If it never extend, the circuit already failed because 1 PB, when you press, cylinder must extend. So if I cannot draw it here, well, I have to draw it as an input, okay, which is on the left, right? So I draw 1LS normally open here first because the question asked me to use. I have to think of a way to use. And I may want to create a control relay, okay? So I'll create another control relay. I call it 2CR. Okay, so the purpose of 2CR is to know that the cylinder is fully extended, okay? No cylinder is fully extended. Okay, let's think about this first. Okay, look at the circuit on top here. Okay, first this pneumatic drive circuit, okay, or this circuit also can. If your limit switch is at original position, it is normally open, which I draw over here, right? Normally open. When your limit switch, when will a limit switch be activated? when your cylinder is fully extended, you will activate this limit switch, which makes it normally open, held, close. 2CR will turn on, and you know that your cylinder is now fully extended. Can I make use of the contact of 2CR to insert in here? Okay, so there are two types of contact for control relay. It's either normally open or normally close. Okay, so let's try the normally close this time, and let's see whether I will get the answer. Okay, so you can see that I choose normally close because I want to allow current to pass through. When you press 1 PB, current can go through, 1 CR will turn on, solenoid will be energized, and your cylinder will extend. Okay, and your cylinder will slowly extend until you reach 1 LS. It will become normally open, held, close. 2 CR will turn on because now you know that 2 CR when it turns on means your cylinder is fully extended. When 2 CR turns on, normally close contact becomes open, right? It will change, right? And no more power to 1 CR coil. Contact will become open again. No more power to solenoid. The cylinder will immediately retract. Okay, so you can see there are two answers to this question. Okay, this is solution 1 over here. Okay, solution 1 is here, and this is solution 2. Okay, and to complete this, I also want to label what's the purpose of 1 CR, which is to energize the solenoid to make the cylinder extend and retract. With this, let's take a look at the simulation circuit to understand this better. We will now take a look at this simulation circuit where this cylinder, once it reaches fully extended position, it will then automatically return back to the retracted position. So how are we going to design a control circuit to achieve that? Well, let's take a look at this circuit, which I have explained to you earlier in the worksheet. So this 1LS again is not activated. So we are using a normally closed 1LS in this scenario first. So as you can visualize, when 1 PB is pressed, okay, the solenoid will be energized, the cylinder will start to extend because the valve is at this position. Okay, and when it reach 1 LS, it will activate the switch, okay, and this normally closed will become normally closed, held open, and it will immediately break this circuit, okay, which means that 1 CR will be off, and the solenoid will be de-energized, which means off as well. So the cylinder will go back to retracted position because the directional control valve will be at this spring position. So let's watch this. When I press 1 PB, okay, momentarily, okay, you can see that the solenoid will be energized. The cylinder will slowly extend, okay, and once it is fully extended, it will activate 1 LS. Look at this, normally close, held open, break the circuit, and the solenoid will be off. The moment the cylinder piston leave, okay, 1 LS, which means that it's slowly retracting, 1 LS will go back to its normally closed position. So how do I make the cylinder extend again? Well, I need to press 1 PB again. So let's watch this. When I press 1 PB momentarily, the control relay will be energized and it will be constantly powered on by the electric circuit. Solenoid will be energized. That's why the valve is at this position. The moment you reach 1 LS, you can see that it will become normally closed, held open, break the circuit. No more power to the solenoid, goes back to spring position. The piston will slowly retracts back, okay? And again, the moment it retracts back, limit switch is no longer activated, so it goes back to its normally closed position. So in this scenario, I can achieve automatic return of the cylinder by using a normally closed 1 LS. How about using a normally open 1 LS? Okay, let's watch the next simulation circuit. Now we'll take a look at this control circuit where we are using this normally open limit switch with an additional control relay, coil and contact. Okay, so when I press 1 PB, okay, the cylinder will extend because the solenoid will be energized. When it reaches fully extended position at 1 LS, you can see that it will become normally open, held, closed because it's activated. Hence, 2CR coil will be energized, the contact will change, it will change to open, and that means that no more power to 1CR, which in turn means that your 1 SOL will be off and your cylinder will go back to retracted position because your directional control valve will be back to this spring position whenever solenoid is off. Okay, so let's watch this. When I press 1 PB momentarily, 1CR coil is energized because of this latching circuit, and you can see the solenoid is on. The moment the cylinder reaches fully extended position at 1 LS, you can see it will become normally open, held, close. 2CR coil will be energized, contact will open, and you can see 1CR is off now, solenoid is off, the cylinder will start to retract. Okay, the moment you leave 1 LS, it goes back to open position. Okay, which means that 2CR coil is not energized anymore. That's why the contact will go back to close. Hence, if I press 1 PB again, the cylinder will extend. And once it reaches fully extended position at 1 LS, you can see it become normally open, held, close. 2CR coil is energized, contact will open, 1CR is off. Okay, and the solenoid is off, the cylinder starts to retract, and you can see that when the solenoid is off, it is back to this spring position for the directional control valve. So this is how this circuit works. We are now back to the worksheet again, and we will take a look at the third circuit for single solenoid directional control valve, which is the time delay control. So when a push button 1 PB is activated, the cylinder will extend. Upon reaching its fully extended position at 1 LS, the cylinder will remain there for a few seconds before retracting to its initial position. Okay, so let's write down the flow of this question first. Okay, when 1 PB is activated, the cylinder will extend. Upon reaching its fully extended position at 1 LS, it will remain there for a few seconds. Okay, let's give it 5 seconds. Okay, before it retracts to its initial position. Okay, so retract is A minus, correct? So as you can see, this question involves timer because there's a timing here. So I will need a timer relay, right? So first, let's take a look at this control circuit. Okay, write down the purpose of 1CR first. So the purpose of 1CR is to control the solenoid, which means that you are making the cylinder extend and retract. Okay, as you can see over here, this directional control valve, when it's at spring position, which is at this check box, the cylinder will retract, okay, because it's entering from the rod side, and likewise, this will extend when you energize the single solenoid here. Okay, the check box will be in this position, the cylinder will extend. So, the purpose of 1CR is to make the cylinder extend and retract. Okay, so when I press 1 PB, 1CR will turn on and the latch will ensure that you have continuous power to the control relay coil. The contact will close, the solenoid will be power on, the cylinder will extend. So let's take a look at this control chain here. So when I press 1 PB, cylinder will extend, which we already achieved, okay, in the circuit. Now, let's take a look. When the cylinder extends and reaches fully extended position at 1 LS, it will wait there for 5 seconds. Okay, so can I say that I would like to start my timer only when it is at 1 LS? Yes, okay, so we should draw the timer as a timer relay coil, okay, in this case 5 seconds, and the contact normally open and normally close, and label please. Okay, so what should we draw over here? Okay, we should energize the coil, right? Okay, so when 1 LS is activated, normally open, held, close, you must activate the timer relay coil. So over here, I will draw the timer relay coil, and please write the preset time, 5 seconds, okay? Okay, so 5 seconds later, you want to turn off the power to 1CR so that it will goes back to normally open position and no more power to solenoid, so the cylinder will retract. So in order to turn off the power, okay, I need to look at 1CR coil, right? So what should I put here? It's either normally open or normally close. The answer is pretty obvious. I will put normally close. Okay, let's visualize again. When you press 1 PB, because your 1TR contact is normally closed, control relay coil will be energized, contact will close, okay, the latch will close, and then solenoid will be energized forever until your cylinder reaches fully extended position at 1 LS. This thing here will become normally open, held close. You will then try to power on this timer relay coil. Okay, 5 seconds later, this timer contact will open. Okay, the moment it open, you actually break the circuit and no more power to the control relay coil. The contact will become open again. Okay, and the solenoid will have no more power. The cylinder will then retract. Okay, so as you can see over here, the flow here, we have already achieved what we want, which is limit switch to turn on the timer relay coil. Okay, after that, 5 seconds later, you break the circuit, okay, which controls the cylinder extension retraction, which in this case is 1 CR. That's why we put normally closed 1 TR over here, so that 5 seconds later you open and the circuit will break. 1 CR has no more power, so now it will be off because this contact goes back to its original normally open position. So this is how this circuit works. So now, let's take a look at the simulation circuit for better understanding. Now we are looking at the simulation circuit for time delay control. So basically, when I press 1 PB, 1 CR will be energized, solenoid will be energized because the contact closed. Okay, so the cylinder extends as the directional control valve is at this position. Okay, and when the cylinder is at the fully extended position at 1 LS, 1 LS will become activated, it will become normally open, held closed. Timer relay coil will then be activated, okay, because normally open, held closed allows current to flow through, so the coil will be energized. 5 seconds later, this normally closed contact will open, okay, and hence the moment it opens, 1 CR will have no more power. When 1 CR has no more power, it also means that your solenoid has no more power because the 1 CR contact is controlling the solenoid. So the cylinder will start to retract. So let's watch this simulation circuit now. When I press 1 PB momentarily, 1 CR will be on, okay, and it stays on because of the latching circuit. You can see that the solenoid is constantly on. The cylinder will extend and will stay fully extended until you reach 1 LS. Look at this 1 LS. Normally open, held close. Timer relay coil will now be energized. 5 seconds later, watch the timer contact. It will become normally closed, held open. Okay, the moment 5 seconds has reached. So you can see that the timer contact now will be open anytime from now because we are reaching almost 5 seconds. So you can see it becomes open. 1 CR is off, solenoid is off, goes back to spring position and the cylinder starts to retract. Okay, and the moment the timer relay coil is off, the contact will go back to its original position, which is closed. However, now 1 CR is already off. Okay, and if I want to make the cylinder extend again, the only way is to press 1 PB. Okay, and let go. So now it will be energized constantly because of the latching circuit of 1 CR. Okay, and when it reaches its fully extended position at 1 LS, you can see it will become normally open, held closed. Timer coil will be energized. Okay, and 1 CR coil is still energized because 1 TR is not open yet. Okay, so let's watch. 5 seconds later, this contact 1 TR will become normally closed, held open. And you can see that the moment it opens, it will break the circuit. Okay, and 1 CR will be off. The moment it's off, solenoid is off, cylinder will start to retract. Okay, and you can see that once the timer relay coil is off, timer contact will force back to original position. Same as the 1 LS, the moment the cylinder piston is no longer touching it, it will become normally open again because it's not activated now. Okay, so that's the end of the simulation for time delay control. We are now back at the worksheet again, and this time round we will take a look at automatic return with initial position. Okay, so the cylinder will extend to its fully extended position when two conditions: the cylinder piston is at its fully retracted position and a push button is being pressed. Okay, so let's write the flow first. So when 1 PB is being pressed and the cylinder is at fully retracted position, which is 1 LS, as I can see from this pneumatic drive circuit, okay, fully retracted position, okay, the cylinder will extend, okay. Then it says, upon reaching its fully extended position, the cylinder will retract automatically. So, upon reaching its fully extended position at 2 LS, the cylinder will retract automatically. So this is what the circuit wants, okay. So how do we do this question? Basically, there are two different solutions. In fact, in IA, we can have many different solutions as long as your answer and logic is correct. Okay, so let's take a look. First of all, look at this pneumatic drive circuit here first. I can see that limit switch 1 is at activated position. So limit switch 1, okay, when it's activated, it can be normally open, held closed, or normally closed, held open. Okay, so we can take note of that first. 1LS, okay, it can either be normally open, held closed, okay, or normally closed, held open. Okay, so because it's activated position. And for 2LS, it is not activated, so it's either normally open or normally close. Okay, sorry for the circuit. Okay, so we can see over here 1LS is normally open, held close, or normally closed, held open, because it's already activated by the cylinder piston. 2LS is not activated, so it's either normally open or normally closed. So take a look at the first circuit over here first. Okay, ask yourself, what's the purpose of 1CR? Okay, again, I can see the contact is driving the solenoid. So obviously, it is making the cylinder extend or retract. So things on the left is actually turning on 1CR. Do you agree? And things in the center will actually break the circuit, which means it turns off 1CR. So who will make cylinder extend? Okay, because only by energizing 1CR, your solenoid will turn on because the contact closed. Okay, and your latch will work also because it will keep energizing the control relay coil and your contact will keep closing. So that's why this is the start condition of the extension. So what are the conditions to make it extend? 1 PB and 1 LS. So over here, I should write down 1 LS. Okay, should I draw normally open, held close, or normally closed, held open? Okay, let's try normally closed, held open. Do you think this will work? No, it will not, because even if you press 1 PB, and because your 1 LS is already normally closed, held open, which means that no power can even go through, okay, so your 1CR will never turn on, your solenoid will never be energized, okay, which is wrong. So I should draw normally open, held, close, okay, which is this. So let's visualize again. When you press 1 PB, and because 1 LS is normally open, held, close, 1CR will turn on, the latch will turn on, the 1CR continuously, and your contact will close, your solenoid will be energized, your cylinder will extend. Okay, and who will break the circuit to make it retract? Okay, as I can see from the control chain which I draw, 2LS will make cylinder retract. So I should draw 2LS over here. So should I draw normally open and normally close? I already learned from previous example that over here I should draw close, so that when it reaches that position, it will open and break the circuit. So I will draw over here normally close, okay, 2LS. Okay, so this is how this circuit works. Already, this is solution 1. Okay, I write here solution 1. Okay, now we'll take a look at solution 2. again, first label, what is the purpose of 1CR? Oops, sorry. What's the purpose of 1CR? Okay, you can see the contact of 1CR is being used to energize the solenoid. So the purpose of 1CR is to make cylinder extend and retract. Because by energizing the solenoid, actually you are making it extend, correct? As you can see from this directional control valve here, one solenoid when it's being energized, you'll switch to these spots. When it's off, it goes back to spring position and the cylinder will retract. Okay, so now this solution 2 introduce another control relay called 2CR. Okay, so what should I put here to make it retract? Okay, as you can see, definitely the answer needs to come from 2LS because only 2LS will make cylinder retract. Okay, but I couldn't draw a normally open 2LS here. Can I draw it here? Okay, and let's visualize again. So when your cylinder has reached fully extended position, 2LS will become activated. So it will be normally open, held, close. It will activate 2CR. So the purpose of 2CR is to make it retract, correct? Because I will cut off the power. So how do I cut off the power? Well, a simple way is to do this. I will draw the 2CR normally close here, just like what I have done in this example part B. Okay, this is actually similar to this. Okay, as you can see over here. So let me go back to the example now. So let's recall how this circuit works again. Okay, so when you press 1LB on PB, and because your 1LS is at normally open, held, closed position, okay, and 2CR is normally closed, so 1CR will be energized, contact will close, solenoid will be activated, and it will stay activated because of this latch. Because when your 1CR coil is being energized, your contact will close. Okay, so solenoid will keep on energized, cylinder will extend. When it has reached 2LS, normally open will become closed. Okay, and you will energize 2CR. So when you energize 2CR, the contact will change. Okay, this contact will change. It will change to open, end up breaking the circuit. 1CR has no more power. When 1CR has no more power, the contact will become open, and no more power to the solenoid, the cylinder retracts. Okay, so to summarize, as so far, do you observe that things on the left is like the start condition, things within this latch here is the start condition, and things that is out of this latch here is actually the stop condition, or I call it the on and off. Okay, basically I'm turning on the solenoid using the condition here, I turn off the solenoid using the condition in the center. Okay, as you can see this as well, when you press 1PB, solenoid will turn on. So things that is on is actually within this latch, things that is off is outside. Okay, so 5 seconds later you turn off and the solenoid will retract, right? So you can see there's a specific pattern to it. Okay, now we will take a look at the simulation circuit for solution 1 and solution 2 so that you can visualize and understand better. In this simulation circuit, we will show you that when I press 1PB, the cylinder will extend and retract automatically with the help of the limit switches. Okay, so as we can see over here at this pneumatic drive circuit, 1LS is currently activated now, and you can see from the control circuit it is currently normally open, held, closed. Okay, and you can look at 2LS now. 2LS is not activated. We can choose to use normally open or normally closed, but in my simulation circuit here, I will illustrate to you how I can use normally closed 2LS to do the control circuit. Okay, which you can see over here, 2LS is now normally closed. So when I press 1PB momentarily, you can see that 1CR coil will be energized, the contact will close. This is the latching circuit, and the solenoid will be energized. Hence, the cylinder is extending because the valve is at this position. But when the cylinder is at fully extended position, you can see 2LS is now normally closed, held, open because it's activated now. Okay, and the solenoid is now off because just now when it opens, you actually cut off the power to 1CR. 2LS has fallen back to normally closed position because it is no longer at its extended position. Okay, so as you can see, 1Ls is now back to normally open, held, closed because it's now activated. So let's watch this circuit again. When the cylinder is fully retracted, 1Ls becomes normally open, held, closed. When I press 1PB, okay, momentarily, 1CR is now energized, contact closed, solenoid is now on. You can see that when it's extending, 1Ls goes back to open because it's not activated anymore. But when 2Ls is activated because it's fully extended, 1CR is now off, solenoid is off, and hence the cylinder is back to retracting because the valve is at its spring position now as the solenoid is now off. Okay, so you can see now the cylinder is now fully retracted. Okay, let's watch for the last time. When I press 1PB, okay, cylinder extends and 1Ls is back to open because it's not activated. 2Ls is still closed, okay, but the moment the cylinder is fully extended, it will be activated, normally closed, held, open. 1CR will be off. Solenoid is now off. The cylinder now retracts back. You can see that even if I press 1PB at this point of time, the cylinder will never extend because 1Ls is not activated yet. It is still not at its fully retracted position. So I could not extend my cylinder. Okay. So the conditions to make the cylinder extend is when I press 1PB and the cylinder must be retracted, which is detected by this 1Ls. The condition to make the cylinder retract is when your cylinder is fully extended, it will activate 2Ls to open the circuit here, and hence the solenoid will be off. The cylinder will then retract because the DCV is back to this spring position. Okay, where you can see that the air will make it retract, okay, because it's entering from the rod side of the cylinder. Okay, so now we shall take a look at how we can use 2Ls normally open, okay, and do the control circuit design. Okay, over here you can see I'm using normally closed, but you can also use the normally open concept for 2Ls. Okay, now we are looking at this control circuit whereby I'm using a normally open 2Ls, okay, to detect the fully extended position. So as we have learned earlier, 1CR is used to control the solenoid, as you can see. So when 1CR turns on, the cylinder will extend because the solenoid is being energized. When 1CR turns off, the cylinder will retract because the solenoid is off. Okay, so who controls the on and off of 1CR? Okay, as you can see over here, when 1PB is actuated momentarily and when the cylinder is at its retracted position at 1Ls, normally open, held, closed, is activated now because it's retracted. Okay, the cylinder will extend because these are the two conditions to make 1CR turns on. So what is the condition to make 1CR turns off? It's actually this normally closed 2CR. So when 2CR open, okay, then 1CR will turn off and the cylinder will retract. So you can see the control coil of 2CR is being controlled by 2Ls. Okay, so how do you know that the cylinder has reached its fully extended position? When you reach 2Ls. Okay, so let's watch this simulation circuit now. And first thing I want you to observe is when I press 1PB, you can see that because the cylinder is already initially retracted, that's why it is normally open, held, closed. Okay, and hence you will observe that 1CR will turn on the moment I press 1PB. Okay, so this is the first observation I want you to make, and it will stay on because of this latch. Okay, let's press 1PB momentarily and let go. You can see that the cylinder is extending now because 1CR is energized. However, when the cylinder is fully extended at 2Ls, the second observation I want you to make is it will become normally open, held, closed. 2CR will turn on, 2CR circuit will open, 1CR will be off. Okay, and solenoid is now off. Cylinder will slowly retract back. Okay, you can see that when the cylinder is retracting, 2Ls will become open again because it's no longer touching, and 1Ls is also open because it has not reached its fully retracted position. So the moment it reaches its fully retracted position, you can see that 1Ls is now normally open, held, closed. Okay, because it's activated now. Okay, let's press again. So you can see that the solenoid is now being energized because 1CR is on, okay? And when 2LS is activated, 2CR will on, okay? Contact will open, 1CR will be off. Okay, and because the cylinder has not reached its fully retracted position, you can see that 1LS is now open. So even if I press 1 PB at this point of time, the cylinder will not extend back, okay? Because 1LS is still open, okay, until it is at its fully retracted position. Okay, so with this, we'll go back to the worksheet. Now, we shall take a look at the last example, continuous cycle, on the worksheet using a single solenoid directional control valve. So, let's draw the flow of this question first. When 1 PB is pressed, the cylinder will extend, okay, and retract continuously until a stop PB is actuated, okay. So, when 1 PB is pressed, the cylinder will extend, okay. And how do you know it's fully extended? You reach 2LS, then it will retract, okay. Then it will reach 1LS. Then after that, it will just go on and on continuously, okay, without the need to reactivate pressing 1 PB again, okay. So you only just need to press 1 PB once momentarily. So now, let's take a look at this electrical ladder diagram first and write down the purpose of 1CR and 2CR. So I can see the purpose of 1CR is to control the solenoid. So to control the solenoid, we are actually making the cylinder extend and retract. Okay, and as I can see from this diagram over here, when I energize the 1SOL, the cylinder will extend. When it's at spring position, the cylinder will retract, as you can see over here. Okay, so next, what's the purpose of 2CR? Okay, I look at the contact of 2CR is here. Okay, so I can see that when 2CR coil is being energized, the contact will change to normally closed held open, breaking the circuit. So when you break the circuit, which means no more power to 1CR, you are actually turning off the solenoid, which means that you are actually making the cylinder retract because you are turning off the solenoid. Okay, as you can see from the contact over here, when 2CR coil is being energized, the contact will become normally closed held open, and hence no more power to 1CR, and 1SOL will not be energized. Hence 2CR is used to make the cylinder retract. So as I said earlier, there's a pattern to every latching circuit. Things above the latch, okay, is actually the on condition or the start condition. In this case, when you turn on 1CR, you make cylinder extend. So the conditions to make the cylinder extend, I'll put it here. The conditions to make the cylinder retract, I'll put it here, which is the 2LS controlling it, right? So that's why we draw 2CR normally closed here. So most students will say this, okay, as you look at this diagram over here, this flow diagram over here, the conditions to turn on 1CR or to make the cylinder extend is first 1LS, okay, which they redraw, and 1 PB, which is what most students will say, okay. Let's draw first. Okay, remember the flow I'm drawing, the flow I'm drawing over here is meant to help us, okay. You can write your own flow diagram to help you to fill in the electrical ladder diagram. So is this answer correct? Well, let's think through this, okay. When you press 1 PB, and because 1LS is normally open, held, closed, 2CR is still closed at the moment, okay, 1CR will turn on, solenoid will be energized, the cylinder will extend. So yes, cylinder will really extend, okay. Once it reaches fully extended position at 2LS, 2CR will turn on, 2CR contact will change to open, okay. Because the coil is energized, the contact will change from normally closed to normally closed held open. 1CR will have no more power, okay, the contact will be open, no more power to solenoid, the cylinder will retract, okay. So yes, when you reach 2LS, cylinder will retract, okay. So when the cylinder retracts and when it becomes fully retracted, it will reach 1LS. When it reach 1LS, 1LS will become normally open, held, closed, okay. And in order to turn on the cylinder again, I need to energize 1CR coil. the contact will close, and then the solenoid will turn on in order to make the cylinder extend. But that's provided I press 1 PB again, okay? But are we allowed to press 1 PB again? No, because the question says, when the start 1 PB is pressed, the cylinder will extend and retract continuously until a stop 2 PB is actuated. Okay, so I could not put a 1 PB here, because when I put a 1 PB here, what I'm creating is only a single cycle action. In other words, when I press 1 PB, cylinder will extend, reach its fully extended position, then retract, and reach its fully retracted position, and full stop. That's it. Nothing will move again until I press 1 PB again. So I'm creating a single cycle action. Now, the question actually asks for a continuous cycle. Okay, so how do I do that? Okay, I will teach you shortly, but before I do that, I will show you the simulation circuit on this first, okay, and why this is wrong. Okay, so let's take a look at the simulation circuit now. Now we are at the simulation circuit where I connected 1 PB over here together with 1LS, and as I told you in the worksheet just now that by connecting 1 PB over here, I will only create a single cycle action. And that's why I want to show you this simulation circuit on why I only created a single cycle action. For those who are confused on what do I mean by single cycle action, it means that when I press 1 PB, the cylinder will extend. Once it reaches fully extended position, it will then retract, okay, and full stop. Nothing will happen after that. The only way to make the cylinder extend again is I press 1 PB again. So let's take a look at this circuit now. You can see that the moment I press 1 PB and the cylinder is at retracted position, 1CL will turn on, okay? What is this position of the 1LS now? It is actually normally open, held, closed, because the cylinder is now retracted, it's activating the limit switch. That's why you draw 1LS as activated position, normally open, held, closed. And 2LS is not activated, that's why it is open. So let's watch this now. When I press 1 PB, and because the cylinder is retracted, 1CL coil will turn on, solenoid will then energize. Okay, so let's watch this. When I press 1 PB momentarily, cylinder will extend. Okay, and you can see 1CL is on, solenoid is on as well. When the cylinder is fully extended position, 2LS will become normally open, held, closed. 2CL is on, contact will open, and 1CL is off, cylinder starts to retract, okay, because solenoid is also off. So the directional control valve will be at this position, which is the spring position. So as you can see, 2LS is no longer activated, it falls back to open position, and 1LS now is activated because it is retracted now. Okay, so it goes back to normally open, held, closed, and the cylinder just stops. Okay, so let's watch again. In order for the cylinder to move, I need to press 1 PB again. Energize 1CL, contact close. Because of the latch, solenoid turns on forever. Okay, even though the limit switch is now open for 1LS because the limit switch is no longer activated. Okay, and you can see the cylinder is now retracting because it has reached its fully extended position just now. And take a look at 1LS. It goes back to normally open, held, closed the moment it is being activated. Okay, so only by pressing 1 PB again, cylinder will then extend. Okay, and this latch is important because it will maintain continuous power to the 1CL, which in turn energizes 1SOL. So 2LS watch is going to close, normally open, held, closed because it's at extended position. That's why the circuit breaks, okay, because 2CL is energized just now. So now let's go back to the worksheet. Now we are back to the worksheet, and we know that we cannot create a 1 PB over here. So we have to create something called a continuous cycle mode relay, okay. So I will draw the continuous cycle relay here, which we have done in video 2, okay. So who will start this auto cycle relay? Well, when I press 1 PB, okay. So when I press 1 PB, ACI will turn on, and this one is a continuous cycle relay, or
We also call it auto cycle. Okay, so if you don't like the name ACR, you can call it 3CR as long as you don't have conflict with the control relay coil here. Okay, just call it a name. Okay, ACR, 3CR, 4CR, 5CR, as long as it's not being used. Okay, but for over here for our syllabus, we will just use ACR. Okay, so that we all understand that it is meant to be continuous cycle. So who will stop the continuous cycle? As I mentioned, things that is on top of the latch is the start condition, which is when you press 1 PB, ACR will turn on. So things that is outside the latch will be the stop condition, which is the 2 PB over here. And I'll draw it normally close. So when you press 2 PB, ACR will turn off. Okay, and I will replace the 1 PB which I have drawn previously over here to be a ACR contact. Okay. So, story cut short, when I press 1 PB, ACR coil will turn on, the contact will close, okay, and ACR coil will remain energized forever, so the contact ACR here will be forever closed, so that when your cylinder is at its fully retracted position, which is indicated here, okay, 1CR will turn on, solenoid will be activated. So the cylinder will extend. Once it reaches fully extended position, it will open the circuit, okay. This thing will become normally closed held open because it reach 2RS, 2CR will be energized. Okay, so you break the circuit, 1CR will be off, the cylinder will retract. Okay, when 1CR coil is off, this one goes back to normally open position and solenoid is off. That's why cylinder retracts. Okay, so when the cylinder is fully retracted, okay, 1LS will become normally open held closed again, and because your ACR is already on, okay, right at the start, okay, and it stays on forever because of the latch here, okay, your cylinder will then extend again, and then this whole cycle will keep repeating until you press 2 PB, ACR will be off. So when ACR is off, it becomes normally open, and the whole thing will stop at the end of cycle. Okay, now we shall take a look at the simulation circuit to understand this circuit better.
Now we are looking at the simulation circuit for continuous cycle, whereby we created a relay called ACR, which stands for automatic control relay. Okay, so when ACR is on, okay, this is the latching circuit for ACR, the contact will close, okay, and it will start the cycle of this cylinder movement. Okay, so when I press 1 PB, I want you to observe that ACR coil will turn on, the contact will close, and because the cylinder is already at retracted position, which means that 1LS is activated, is at normally open held close, so this start condition will be activated, 1CR will be energized, and when 1CR is energized, solenoid will be on. So I want you to observe this first. So when I press 1 PB, momentarily, you can see ACR is on, the cylinder is initially retracted just now, so that's why 1CR turns on and solenoid is on. Okay, and because 1CR has the latching circuit, you can see that 1CR coil is always energized until 2LS is activated, and you can see the 2CR just now actually open to break the circuit for 1CR, and the cylinder is now retracting. Okay, but because ACR is always on, because it's for continuous cycle, you can see the contact is always closed. When LS is activated again at retracted position, 1CR will turn on, contact will close, solenoid will be activated, and when the cylinder is at fully extended position, 2LS will close. Okay, and 2CR will be energized. You can see 2CR open, 1CR is off. Cylinder starts to retract back again. And you can see that 1LS is now normally open because it's still not at retracted position. But the moment it reaches retracted position, it becomes normally open, held, close. 1CR is on again, and cylinder extend because solenoid is on. So when 2LS is activated, watch, 2CR will be on. Okay, because 2LS will be normally open, held, close, 2CR is on, contact open, 1CR is now off. Cylinder starts to retract because it's at this valve position. And again, 1LS, you see, it's not activated yet. That's why it's forced back to normally open. But the moment it reaches here, normally open, held, close. Okay, because it is at retracted position, cylinder will extend again. So you can observe that over here, these are the conditions, okay, to make the cylinder extend, which is the continuous cycle relay and the retractor position. And this is the condition to make the cylinder retract, because this is where you cut off 1 CR circuit and no more power going to the solenoid. Okay? So how am I going to stop this cycle? This cycle will keeps on going on and on again, as you can see over here. Okay? So the only way to stop this cycle is to press 2 PB, okay, and ACR will goes off. Okay, so let's watch. When I press 2 PB momentarily, ACR is off, okay, and you can see that even though the cylinder later on reaches fully retracted position, 1LS, 1CR will never turn on again because ACR is already off. Your continuous cycle relay is already off. Okay, so that's the end of this simulation, and as you can see, this is how you can create a continuous cycle motion by creating an additional control relay. We call it ACR, okay, and it's being controlled by 2 buttons, 1 PB to start the continuous cycle and 2 PB to stop the continuous cycle. Okay, with this, we have already finished the entire chapter for Electro-Pneumatic Worksheet 4, whereby you learn about latching circuits, how to control single solenoid, double solenoid directional control valve, how to control a motor circuit, and you need to apply all this knowledge later on in your subsequent topics.